everyone. I am Mr. Desat today, and today we are going to learn about dams. Wait a minute. Markers, which are the most important of this video. So I am going to tell you now. So what does a dam do? See, when does a river flow? There is a big bank. Here, the water is going into the another river or into the sea, which puts lots of fresh waters straight into the sea, creating them to salt waters. So, here dams, what dams do is when you create a dam, it holds back the water which can be used for irrigation purposes, hydroelectricity, or simply to prevent flooding. So here I want to tell you our types of dams. So now there are three types of dams. First of all, there is a normal dam. A normal dams can be seen everywhere. It is most commonly used type. Right? These dams are used to create it mostly for hydroelectricity purposes or sometimes for irrigation purposes. So these dams have a lot of change. They are simple flat. These dams are currently mostly made out of concrete and they hold back water. They also take little bit help from the gravity so they can reduce the uplift forces. I'm going to tell you when I want to tell the gravity dam. So now, a gravity dam. And now, by the way, most common the dam I know which is the Korna Dam, which is in Maharashtra. There are a lot of cases also, you will see a lot of videos about that dam also. So now, I'm going to tell you now about the gravity dam. See, gravity dams are mostly used to prevent flooding or irrigation purposes. These dams can be made out of soil. They use whole lot of gravity. Since these dams do not have a nice area, so they can create an uplift force. Now I'm going to explain how uplift force. See, here when there is water, so in the water it has density. So for example, if the water has 8 atoms, which I don't, it doesn't have. Yes, it has one water molecule has 3 atoms. So here 8 molecules of one water. So soil is little bit. So here soil has a little bit more density, about like 9. So the soil absorbs the water. And here is the main problem: buoyancy forces. So here everybody knows the Archimedes principle, not the principle of a school. It is a rule, physics rule. Here, if the density of the object is lighter than the object you have kept on it, it will float. Like for example, like water has a density of 8. Has a density of 8, oil has a density of 6. So, since being less density, it will use the Archimedes principle and stay on the top of the water. And that's why most purification and oil purification, which are on the oil drills, use this process. Like in the sedimentation. And here, the water and the impurities of the oil will go down and we will get fresh crude oil on the top. This this is one example, but here this is an example of a buoyancy force. And you can know, in the Dead Seas, the water molecules are around 8 to 10. And from 8 it is going to 10 Dead Seas. So the higher quantity of soil. And here, as humans, which have a density of 9, will float on top, and how much we try to sink in, it will not. We will straight go back up. It is known as a buoyancy force. So here in a gravity dam, and there is a layer of soil, layer of rust. See, here the water goes, applies pressure, and the most pressure is applied at here. This point which I have encircled is where the most pressure comes. But then the water seeps in into the ground, which results in more uplift forces. Which is why these gravity dams have a risk of leaking in waters and can be damaged. In order, it can leak water. So that's why most of the dams which are created today are built on a layer named hard strata. So in this layer of hard strata is made out of fully rock. Sorry for that. It's made out of fully rocks which reduce the seeping content. Rocks cannot stop seeping since nobody can stop water. Water can. What is the universal soluble liquid? It can seep in anything. It can break the components of the rocks and seep in. But the force of the water seeping quantity will be much less than the topsoil, which is over here. The topsoil, which will absorb more water. And yeah, mostly these dam areas where the gates are made, those areas have mostly clayey soil or loamy soil. And this soil can absorb very high water. Clay soil can absorb very high water. That's what used to create idols and structures. Then, after this, they create. So in the hard strata, the water absorption rate is very less. So if the water here, topsoil, the water absorbs here, and with a layer of 2 density of 2. So here the water can absorb. But on the hard strata layer, it has a density of, for example, 20. So water will seep in very less. And mostly only this much part, the topest point. And dams are created in the middle of the hard strata. Means in the middle, down the same distance, up the same distance. So water cannot go inside. So now, the third type of dams is arch dams. Is arch dams. You know what is an arch? It is the most commonly used design. Right? Means lot of bridges use an arch. For example, the Chenab Bridge, which is made on the river Chenab. This uses an arch. in a straight line is a problem. There's some gaps here. There's some gaps. So it can literally destroy. But in a curve, those gaps are destroyed, even making them stronger. That's why most of the arch bridges has arch-taken. Venice, all dependent on arch. So here the arch dam. See the arch dam. Here how they work. So there is a hilly area here, and the arch dam is created. There's focal points here. Let's also use all gravity. Note that all dams use gravity to stop water, but one little extent. Here the water pressure comes. In a water pressure, when the water comes down, in this water pressure, and it will not able to bend since the top part is in the bottom part is in compression, the upper part is in tension. So we try to keep it into compression. And concrete is good in compression, but not good in tension. So this pressure will create and will try to push the concrete trying to create compression over that. So if there is a arch like this, they will shift about like some 1 to 2 millimeters or something, but they will flat straight. So then here the top portion gets compression, and then the dam stays at place. I want to show you an actual representation in this soon. So let's meet you there. Okay. So guys, I'm going to show you now a visual representation. So here I have created the bathtub into this. I'm adding now paper straws as a rebar. Sorry, if there is echoing, I'm sorry for that. I can't do anything about it. I have to wait and wash my hands first, then I can show you the actual representation. Wait a minute. I'm going to take the excess part and I'm going to add it here. This is going to be the reservoir part over here, and this is going to be where the water will go. So this will be like the canal of area. And some sand here. Since sedimentation happens, I'm adding sand. So now I have added straws here, and now I'm adding some straws which will act as the road here. Which will act as a road on the dam. And this will also help in strengthen the part of the dam. Sorry, I can't show you the side of the equation. So now I will show you when I fill water. So now let me explain you how the dam works. So here you are seeing the soil here. Here. I know soil is not. This is the soil of the construction of the dam, but I want to take it as a topsoil. Then the plastic tub, the bottom of this tub will be shown as the heart strata. I know heart strata is not this much high. Actually, heart stratas are very low in the ground. But let's check. So now I'm going to add water. Check out. Our dam is stopping the water. So as you can see, here the reservoir part is full, and here the water is coming from here to here. When the water over here will be leveled, then water over here will be leveled. So now I want to add here, and now I want to stop this. I will stop this. So here how the dam works. So this is I have created a representation of a flood dam. So in this type of dam is used to stop a flood. I have added some these roads, so it can help to create the road. So now let me add this. I'm now going to add a reservoir canal. So what is the extra water during the irrigation process? It will also act like the only gate, and it will become a representation in the top of the Sanolim dam. So let me show you. I remove this. Now you can see water is coming through. See, if I add sand over here, see, water is coming through here, and as this is straw level over here, the water will go. So now as you can see, the water is coming from here to here. Dams, this can have some problems. See, if the dam get destroyed, means if one of the portion get destroyed, like for example this, another gate has opened water. Another gate. So this dam can little stop the flowing of water. So I will let the water go over here. And here now the sand has gone into sedimentation part. So now I am going to now transfer this. Here I transfer this water into here. And yeah, first of all I have to now drain this entire part, and I have to clean this part here. So I will show you. Now I am going to add the water here. I have now made sure that no water can escape from here to here, and now I am putting the water over there in this side of the dam. So now here this looks like chocolate, by the way. I don't know who is the fan of chocolates. Willy Wonka. So now all the water except some of this water almost all of the water has gone. Now as you can see, this part which was under the water is known as the sediment. So this sedimentation happens. Now here the sedimentation process will happen. And by the way, it is raining outside. So now I'm going to wash my hands now. I know my hands will put chocolate. So here the mud which is coming here. So now here as you can see, here sedimentation mud is coming. And then as you can see here now. Wait a minute, I'm going to increase. So now, as you can see here, so here I am touching the part. It is sediment. I will tell the part of the sediment later in the other process. And yeah, guys, this sediment can be dangerous from the dam. And then I'm keeping this part up. So here, now here, part here. And let me just reduce it back to normal. So now you can see here. So in here part there is a water, and in here part there is a filling. So if we take out, so now I'm going to take this straw. So let me just dry it. See, now I'm going to keep the straw from here onto here. So this will be a part. So now I have now added here. Now you can see what is coming through here. Let me just fill up this part. You fill up this part. You take all the water back up. I will keep it now away. Wait a minute. It is very difficult. I don't know how did Abdul Ali just carry him just with 3 fingers. Since I cannot do it with 3 fingers. So now here as you can see. See guys, here the water is leaking here. So I'm going to close it here. I'm going to add some sediments. So now the water process has finished. And let me first add all the water back on the top. And let me just secure this back into the original place. Since while keeping all the water here, but the top has a base of this straw. I remove the straw. This straw has a rebar. So this straw acts as a rebar which makes the dam stronger. That's why when you create concrete structures, you want iron rods which help in strengthening of the structure. And here now in my hand is the sediment of the water, and I think here will be some sediment also. Check out the sediment in this higher water part. And now there's 2 types of sediment, heavy sediment, bottom sediment and top sediment. So bottom sediment, I'm going to show you bottom sediment. So this now in my hand is now bottom sediment. In my hand is bottom sediment. And now here in the top of the water, now this is the top sediment over here in my finger. So this is the top sediment. So now how does the dam look? This is known as a flood dam. It holds the water, so flooding doesn't happen. And if water level also increase, the water level will go only the part which is above the water will go. Like my trick. And this is why dams are created. Some dams. So now I'm going to create a hydroelectric dam. So now let me clean this. Let me clean this. So here is our hydro. Here is now our turbine. I know straw doesn't looks like a turbine, but it's going to be a turbine. So now I'm going to add this here. Add this here. So now the water has started to come. So now the water is coming here. So I added some sediments on the top so that it will take the water from the bottom. So now straw will work done. And let me clean this area. So now here a gush of water has appeared. Let me show you. Okay, now a gush of water is appearing from here. As you can see. As you can see, the gush of water is appearing from here. Let me just make the gush of water even more. So now the water from here will come here. Now here's sedimentation on the bottom plant. So this sedimentation, now let me show you again. So now I have made a hole. Now let me fill back the hole. Wait a minute. Let me fill back this hole. And let me make this dam even higher. So now I'm going to first take all the water, first straw. I have now cleared the straw. And now I'm going to take all the water back. Towards the top. This process takes a lot of time. Now here I can take the entire thing back. I can take the entire thing back. But here, as you can see, the height increase of the dam has taken some turn. Now here this part is now strong. And now here, now you can check this part now. Wait a minute. So now here, as you can see here, it is now sedimented. It is the sediments which have been occurring here. So now I'm going to keep it. Now take all the sediments which are appearing here and take them back here. Here the dam needs to be strong. Your dam needs to be strong. So now I've strengthened this part. Now, this is again, I'm gonna take another straw this time, not this much. So now I have created the elementary color. So now, as you can see, the water is coming here. But let me turn this. Let me turn the table. I will just strengthen this. And it's sending water back here also. But this part has nothing there. A dam's edge is like literally dying now. Now, literally, this much, I keep the sediments over here. Now, I will keep the sediments here. Any sediments here? Sediments I will add over here. More sediments? I will add over here. Any more sediments? I will add it here. I'm going to add the sediments here. Now my hand is getting dirtier, but for you guys I'm creating. It's like literally 12 minutes. So now, here, now let me bring it back to you. So here now we have our two parts. I have to literally be very careful with it. I keep back all the water here. Now, here's the dam. Here's the thinnest part of the dam. It is supported by two strong bars. In this part, here, if you create the gate, now I create a gate here. It's not from here, in this part. Let me stop. Stop it. I said stop it. See guys, nothing can stop the water. The water is still there. I take now this step and add it again. Here now here's a simple step of it. Here now I've straightened this out, and now as you can see it is getting shorter. And that's simple. king of the area. And check out the sediment, guys, bro. This is the bottom sediments over here. This is the bottom. I had to take this off. And these sediments are the top sediments. These have a lot of sediment here, but it's muddy water. So let me tell you one last time. Let me show you the again. As I leave this, the water is in gushing. It is gushing in. And from here, the water is coming back. Here, I have to shut down this gushing in water. And let me show you again. And here is my erosion. Now this is the bottom rebar just shown. I'll take the excess part and keep it here. I keep the excess part here. I know this video takes so much long to keep the water. So now, all the sediments here, now I've added here. So now, I'm going to show you again. So now here, the water is gushing in from here, and here, and now here, there's a deep void. So the water is trying to go in here. But the sediment stopped. I know my left hand's entire job is now to do this. Any more sediments? I'm going to add it here. The whole is still there. But the sedimentation again happens there. The solidified the structure. What is it? Solidified the structure. So now I will show you again. So this part is lower. So this part is lower. So this part is lower, this part is higher. So now I am again gushing in. Now the water is gushing in from here to here. And here now there is a deep point. So the water is trying to gushing from here. But till the time the water level is same, it is going to happen again. So wait, I will bring some more water. And then so now I bring some more water. I want to put this on this side. And now again, see, here a deep point happened here this. Now when the dam is now getting this much dam into here. And now here, now the dam portion is here. So now hope you like this video. Huh? So this is how the dams work. Now, once we create things, the dam is also destroyed. So when water erosion happens, the dam get destroyed, and then the paper also don't get destroyed, but and then let's keep on in the water. We just keep on in the water, and then it is all mixed and then the sediment happens. So dams can also collapse. But this way we collapse it like I did, it doesn't happen like that. So I will just show you again in the reproduction in the main part. So now here guys, here now in the top is nothing but only sediment and the remains of the dam we created. So these sediments can be dangerous for the dam. See, as the water moves, the sediment collect here, which means less reservoir space. As the dam moves, there is more sediment coming, and then it means less reservoir space. So, hello everyone. How do you like the physical experiment which we have done about the dams? But one thing I told you, the sediment which used to repair the dam. But as you can see, in the starting of the video, in the starting of the experiment, the dam was this much. But when the time I collapsed the dam was about this much. How this will happen? This is called erosion. And gravity dams like Salween Dam in Goa are in great danger because of this erosive power. See, here, gravity dams first have that weakness that the most power is the uplift force, which I think will be little bit only because of the hard strata layer, but still there is a uplift force. On top of that, the water which is coming has a high force of power. So, as you know, rivers tend to be bend. Like, there is a lot of bend. And I once imagined a river which went like this. Here straight, here you came like that, like this. But here, a great bend. Here, how do the rivers move? See, here is the river. Let's just take out. So now, here is a river. So let's take out this portion here. So here, this is erosion. See, here water goes here, over here. So in this, yes, it creates erosion which takes it more. And when it becomes so short, it is very close. And then when they meet, it joins. And the river follows, and the river follows straighter path. Which in consequence, the leftover or main dots are turned into oxbow legs. So that is the thing of erosion. But how does it affect to gravity dams like Salween Dam? So let me tell you. So here, the water applies a great force which tends to break some parts. Eventually, the distance so at one push then the entire thing is destroyed. So they have to put maintain check. Since you cannot check from this side, you have to check from the outer side and make the side from the outer side stronger to the inner. So erosion happens less. And then that's why when they create a reservoir, the high pressure wait a minute. river creates a reservoir. So here's a dam, here's a reservoir. The river part starts here. So it's given long area. So here the waters come slowly. Since the massive area are found by the water comes slowly. And the erosion happens less. Some delta islands which are stuck, which are in the reservoirs are created by the process of sedimentation, and this can reduce the area. This can reduce the area, the water capacity of the area. Remember the experiment I showed you? Here I told you sediments which are formed. These sediments were bring in by the river. In the experiment, these sediments were created by the dam, but actually, in real life, the sediments are carried by the soil and then come into the reservoir. But what happens like this? See, here is a dam area, and then here is the land area for the dam. It is on hot strata. So here, then water comes, sediment comes. The first sediment layer nothing, but as over time the sediment layer increased, and then here the water comes fast. So if water wants to go towards here, it becomes fast. So here, then the sediment will come here, and then once it almost fill, then the water will have a nice run to come over the dam. And this can also happen while here. So here, water comes from here to here. Here cause it can break the areas. And that's why a lot of time near the gates in the Sanalam Dam, when I visited it, it was something like this. When I visited the Sanalam Dam, it had something which blown my mind. See, here a water lake stream was coming. See, dam was here. Dam was here. So the water in a concrete structure in there, the water which is over the dam comes and then it flows out into a canal. That I'm pretty shocked. Even my dad said to the security officer who was at the bottom road that इससे फ्री का इलेक्ट्रिसिटी आप जाने दे रहे हो. My dad said to the security. But I don't know why they created that for irrigation. I also personally think how much hydroelectricity power and the Sanalam district will get power from this one gate. But it is used for irrigation purposes. I can't do anything. But the fertile soil comes. But the sediments here, fertile soil sediment. This sediment come from the upstream, has some nice which have nutrients. So in the area, they use this sediment and nutrify this. So except this, the sediments are a great danger for dams, since they reduce water capacity of the dams. And the lesser the water capacity, the more problems arise. See, and then I'm going to create a pie chart. No, not a pie chart. Okay. So here pie chart. So out of the world, 97% water on the earth, which is in ocean and sea, are salt water, and only 3% of them came from fresh waters. From the fresh waters. And from that fresh water, 3% we clean the whole. Only, according to me, 26% of 3% water supply are just this. Are just dams. Are just dams. So, I would like 0.7% of the world's entire water is dam reservoir water. So here, now, hope you like this video. We'll meet you in another episode. Bye bye. Bye bye. Wait.